This is pre-algebra lesson 2-1, solving equations by adding or subtracting. Inverse operations are operations that will undo each other. For example, subtraction undoes addition, multiplication undoes division. Okay, turning off a light undoes turning on a light, untying a shoe undoes tying a shoe. Whenever we solve equations, we want to have everything in balance. It's like a teeter-totter. If one side of the teeter-totter is too heavy, the toy does not work properly. In equations, if one side of the equation is unbalanced, the equation does not work properly either. To solve equations, we will use inverse operations to keep the equation balanced. Okay. The subtraction property of equality and the addition property of equality are very similar. Basically, if you subtract the same number from each side of the equation, you keep your equation balanced. For example, 10 equals 2 times 5. 10 minus 5 equals 2 times 5 minus 5. As long as we subtract the same number from both sides, our equations stay the same. So if A equals B, A minus C equals B minus C. Same thing with addition. I can add the same number to both sides of an equation without changing the equation. 8 equals 2 times 4. 8 plus 3 is going to equal 2 times 4 plus 3. Same thing. So, to solve equations involving addition and subtraction, simply undo the operation on both sides of the equation and solve. In other words, whatever you do one side of the equation, absolutely, positively, every single solitary time, without fail, must do the exact same thing to the other side of the equation, which means you have to show that you did that. It's very, very important to me. You have to show it. So if we have these equations right here, x plus 8 equals 3. First of all, you have to know what separates one side of an equation from the other side of the equation. That would be the equal sign. The equal sign divides an equation into two parts. Okay, so there's my division sign between my two sides of my equation. Anything to the left side of the yellow is the left side of the equation. Anything on the right-hand side of the yellow is the right-hand side of the equation. So I'm going to solve this equation. If I look at this, x plus 8 equals 3. 8 was added to x. We need to undo that because x likes to be all by itself. So, if x plus 8 equals 3, we need to undo that. So, to undo addition by 8, we will subtract by 8. So if I subtract 8 from one side of the equation, I must subtract 8 from the other side of the equation. And I must show it to both sides of the equation. And please do your equations vertically. They work so much better vertically than horizontally. Negative 8 and positive 8 becomes 0, which leaves us with x. Because x likes to be all by itself, x is very happy now. And 3 minus 8, 3 plus negative 8, is negative 5. So x equals negative 5. We can check to make sure that this is actually correct by plugging in negative 5 for x every time we see x. So I have negative 5 plus 8. Does that equal 3? Yep, 3 equals 3. It checks. You should be able to check every single solitary equation to make sure that you are right or wrong. Let's look at number 2. 5 equals b plus 1. Again, I'm going to separate one side of the equation from the other. If you look at your equation, 1 was added to d. The opposite of adding something is subtracting it. So I'm going to subtract 1 from both sides of the equation. Positive 1 and negative 1 becomes 0, so that becomes d. 5 minus 1 is 4, so d equals 4. And 4 plus 1 does equal 5, so that checks. And you might say, I can do these in my head, Mrs. Sheeline. Why do I have to show the word? Because I said so, because even though these are easy, you have to get in the habit of doing them correctly now when they're easy. So that they'll be easier to do when they're more complicated. You'll know all the steps, and you'll still remember how to do all the steps. Number 3, y minus 5 equals 8. Again, if I separate my equation, and if you have to draw little lines, that's perfectly fine. You can do that. It doesn't bother me at all. They subtracted 5 from y. The opposite of subtracting, adding. So I'm going to add 5 to both sides of the equation. So whatever I do to one side, I have to do the exact same thing to the other side. Otherwise, the teeter-totter is not balanced. So I can't just write plus 5 on the right-hand side without showing it on the left-hand side. These two things cancel out, leaving me with y. 8 plus 5 is 13. And I'm done. Number 4. Again, there's the left and right-hand side of my equation. 98 equals x minus 14. So 98 equals x minus 14. So they subtracted 14. I need to do the opposite of that, so I'm going to add 14 to both sides. Negative 14 and positive 14 becomes 0, so this is x equals, and 98 plus 14 is 112. Okay. Yes, some of these equations are very, very simple. We start out with fairly simple ones so that you can get into the habit of understanding how to do fairly simple ones, so that eventually you can graduate to more complicated ones. Yes, they may be easy. Yes, you might be able to do a lot of them in your head, but you need to do them on paper like I've shown, so that when they become more complex, they'll be easy for you to do. Now, word problems will simply be transferred to an equation, then solved as we did before. So, what we need to do with word problems is you always need to define a variable. That's always your number 1 step. And your variable is normally going to be defined by what the question they ask you is. For example, Cora measures her heart rate at 123 beats per minute. This is 55 beats per minute more than her resting heart rate R. Write and solve an equation to find Cora's resting heart rate. So our variable is going to be Cora's resting heart rate, which they already told us was R, so we already know that. So let's let R equal Cora's resting heart rate. And you always need to have variables, and you always need to define them. Okay, don't just assume somebody knows what your variable stands for. Always write your variable out and define it. Okay? So, it says, Cora's heartbeat measures 123 beats per minute. 123 beats per minute. This is English. This is a pronoun. This pronoun is going back to her heartbeat. So, her resting heartbeat, her heart rate, 123 beats, that's an equal sign, is 55 beats per minute higher than her resting heart rate R. Okay, 55 beats per minute higher than her resting heart rate R. So that's 123 equals 55 beats more than means that her resting heart rate comes first. 55 beats more than her resting heart rate R. So there's your equation. 123 equals R plus 55. Okay, to solve this, they added 55 to both sides, so we will subtract 55 from both sides. Cancel that out, that means R. 55 is 15. 65 is 11, so my resting heart rate is 68. Since it's a word problem, I have to write my answer in a complete sentence. So Cora's resting heart rate is 68 beats per minute. Okay, let's do another word problem. A softcover book costs $17 less than its hardcover edition. The softcover costs $5. Write and solve an equation to find the cost H of the hardcover book. Okay, so they already told us that H is the hardcover book. You can see that right here. H cost of the hardcover book. So let H equal cost of hardcover. Softcover book costs $17 less than its hardcover edition. Okay? So I'm just going to put it softcover is $17 less than hardcover, right? I just took all of that, just made it into one phrase. So now I'm just going to write what I know. Softcover costs $5. Is equals $17 less than hardcover. Hardcover is H. $17 less than that is. But it has to be H minus 17. It can't be 17 minus H. So here we have that. So softcover is 17 less than a hardcover. So to solve this equation, I subtracted 17. I will add 17 to both sides. So 22 equals H. So the hardcover edition costs $22.